In this short video, we're going to talk about how to solve the geometry problem in this year's AMC10A. This is from problem number 20 in 2020 AMC10A. First, let's draw the picture. Here we know there are two right triangles, ABC and ACD. And we know side length AC is 20, CD is 30. And one diagonal BD cut the other diagonal AC into two parts, AE equal 5 and EC is 15. If you draw the picture, you will notice that BC has to be longer than AB, otherwise it will become hard to draw the AE accurately enough. Let's think about how to solve it. We need to analyze the information. From the picture, is there any hidden information? Not very obvious. What key information is required for us to solve the problem? We know two side lengths of one right triangle. We can find the area of it very quickly. The other right triangle, we only know the hypotenuse. But we know if we draw the altitude from B to AC, and if we know the length of that altitude, we can solve the problem. But how do we find it? We need to ask what have we learned, or what tool do we know to solve the problem? Let's look at the next slide. This is what we have learned in one of the geometry classes during this season. I'm highlighting the central part in this picture. As we learned in any right triangle, if we draw an altitude to the hypotenuse, we cut the hypotenuse into two parts, x, y. We can use these relationships to find out x, y, as well as the altitude h. So leveraging this information, we can solve the problem. First, we draw this hidden line, the altitude in this right triangle. It cuts AE into two parts. One is 5 minus x, the other is x. This will visualize the hidden key information. Let's find our relationship in algebraic. From the formula we learned from the right triangle, we know this equation. But how to find x? It turns out that there is a pair of similar triangles here. And by using this ratio equation, we can find question mark altitude as well as the x. And done.